Hello Titans, this is Mr. Sturts. We are on lesson 5.6, which deals with graphing linear equations with two variables. So pause the video here a second, write these two vocab words down in your student journal. The first one is the graph of a linear inequality. That's what we're working with today. That's the graph with two variables that shows all the solutions of the inequality. The second vocab word is a half plane, which is two regions that the line we're going to graph today, that'll split our coordinate plane into two half planes. It's divided by what we call a boundary line. Alright, let's do a couple examples of whether or not this is a solution. Okay, now think back to previous sections. All we need to do to figure out if it's a solution is plug in -1 for x and plug in 9 for y and see if it's a true statement. Okay, so we're going to rewrite that. Plug in -1 for x. Plug in 9 for y. That's less than or equal to -3. We got to see if this is true. Okay, remember, if it's true, it's going to be a solution. If it's false, it's not a solution. So -2 plus 9 we know is 7. So we have to ask ourselves, is 7 less than -3? Well, we say that's not true, so it's not a solution. Okay, not a solution. Let's look at B. Plug in 2 for x, -2 for y. So we have 2 minus 3 times y, which is -2, greater than or equal to 8. See if this is true. 2, we have a -3 times a -2 is a +6. 2 plus 6 is 8, so we have to ask ourselves, is 8 greater than or equal to 8? It's not greater than, but it is equal to, so that is true, so it's a solution. Okay, just like equalities, but now we have an inequality. We have greater thans or less thans. Okay, here's our core concept. We are graphing inequalities with two variables. Okay, the first step when we graph these is we need to graph the boundary line. We're going to be given an inequality. We're going to use the dashed line if it's not or equal to. If it's not equal to, but it's going to be a solid line if there's a little bar underneath, if it's less than or equal to or greater than or equal to. That's very important to remember. The solid line, we include all the points on that line in our solution. But the dashed line, the points on the line are not included in our solution. Step 2, we're going to test a point that's not on the boundary line. Okay, the point we're usually always going to use here is 0, 0. But 0, 0 cannot be on the boundary line. So if it is on the boundary line, we might use something simple like 1, 1. Okay. Now step 3, when the test point is a solution. Okay, if 0, 0 makes that inequality true, we're going to shade towards the origin, point 0, 0. But if it's not true, if it's not a solution, we're going to shade away from the point 0, 0. Example, we need to graph just y is less than or equal to 2. Okay, we remember when we saw y is equal to 2, we knew that was a horizontal line that passes through the y-axis at 2. Now the other thing to make sure we know, it's or equal to, so it's got to be a solid line through 2 on the y-axis. Okay, solid line because it's or equal to. Now, our test point, we said we were going to use 0, 0. Let's use the coordinate or the y-coordinate 0. Okay, and that's right here. The y-axis at 0. If we plug it in, see if that's true. Is y less than or equal to 2? Yeah, that's true. So we're going to shade towards that point. Okay, in general, we can also say that if we have a less than sign, we're going to shade below the line. Greater than sign, we're going to shade above it. Okay, let's look at this graph here. We need to graph this inequality, but we can't yet. Okay, we can't because it's not in slope-intercept form. So we're going to need to do some rearranging here. Let's move our x first. Let's move our x. So we're left with 2y greater than, let's write our x first, so it's closer to slope-intercept form, x plus 2. Okay, we're not quite done. We got to get the y all by itself. So let's divide everything. Don't forget to divide everything by 2. So now we're left with y is greater than, well, we know there's a little imaginary 1 before that x, so 1/2 x, 1/2 is our slope, plus 2 divided by 2 is 1. Okay, we have it in slope-intercept form. Let's graph it. Our y-intercept is 1, so plot a point at 1. Our slope is 1/2, up 1, right 2, up 1, right 2, up 1, right 2. We know we can also go down 1, left 2, down 1, left 2. Since it's not equal to, we're going to do a dotted line, a dashed line through those points. That means that the points on that line are not included in the solution. Okay, our last step, let's use our test point. We said our test point is 0, 0. So when we plug that in for x and y, we're going to plug in the origin. Okay, that origin is right here. Okay, this is our origin, 0, 0. So let's plug in 0 for y. 0 is less than 1/2. Plug in 0 for x plus 1. And solve it. We got to see if this is a solution. Is 0 greater than, well, 1/2 times 0 is 0. Plus 1 is 1. Is 0 greater than 1? No, that's not true. So it's not a solution. So we're going to shade away from our test point. If it was a solution, if that was true, we'd shade towards the origin. But since it's not, we're shading away from it. Okay, and also in general we said when we have y on the left side of our equation, if we have a greater than sign, we're going to shade above our boundary line. If it was a less than, we're going to shade below. We got to keep in mind that that y needs to be on the left side of our inequality, though, for that to work. Okay, so all the points above that dotted line make that inequality true. We could plug in any point in the shaded area, and that would make that a true inequality. All right, last example here. We have a little application problem. We're going to buy some red peppers and tomatoes to make some salsa. Okay, and we only have $12. We can't spend any more than $12. We know that the red peppers, let's call the peppers our x variable. And let's call our tomatoes our y variable. Okay, so we have x and y. We need an inequality. Okay, we know that red peppers are $4 a pound, tomatoes are $3 a pound. We need to write and graph an inequality that shows how many we can buy for our salsa. All right, let's see. So let's write our inequality. We know that peppers are $4 a pound, so 4x. Tomatoes are $3 a pound, 3y. At most, $12. At most, well, we can't spend more than because we don't have more than $12. That's all we have. So we have to spend less than, but we could spend all 12. Okay, what they want us to do is graph this. Okay, so we're going to have to make a graph, but first we need it in slope-intercept form. So let's move our 4x to the other side. We have 3y is less than or equal to, let's write our x's first, negative 4x plus 12. Divide everything by 3. So what we have left is y is less than or equal to negative 4/3 x plus 4. Okay, let's graph it. We're going to sketch a rough graph here. So our y-intercept is 4. So we're going to go up to 4, plot a point. Let's make our slope. Our slope is down 1, 2, 3, 4, right 3. It's or equal to, so we're going to have a solid line through those 2 points. Let's use our test spot. We said was 0, 0, so let's plug in for 0. 0 is less than or equal to negative 4/3. Instead of x, we're going to put a 0 plus 4. We got to see if this is true. Is 0 less than or equal to 4? Yes, that's true, so we're going to shade towards 0, 0. We're going to shade towards the point 0, 0. Okay, now, really, for this graph, all we need is the positive because you can't really buy negative tomatoes and negative peppers. Okay, so what we're going to actually only focus on is this little positive area right here. Okay, so any points inside this little positive area would make this inequality true. So they say to identify 2 solutions. Well, we could buy, if we go to the point 1, 1 in there, okay, right here, it's hard to see, we could buy 1 pepper and 1 tomato, and we'd still be under our $12. So 1, 1 would be a possible solution. We could buy 2 tomatoes for x, or sorry, we could buy 2 peppers and 1 tomato. That falls in our shaded area. Okay, we got to make sure it's in the shaded area. That's a true solution. Okay, those could be 2 possible solutions. We could also buy maybe 2 tomatoes and 1 pepper. That would work as well. Okay, anything in that shaded area. All right, now that we're done, turn in your student journals to page 160. Complete these 4 problems. Bring them with you to class tomorrow, and we'll discuss them. Thank you for listening. Have a great rest of your night.